Today I'm going to talk about building better style sheets with BEMIT. So a bit about me. I'm a developer, but I actually went to school at a design school called the Art Institute of Pittsburgh, which as a front-end developer was really great because it rounded out some design knowledge that I may have otherwise not had. Most of my career has been focused around agency work, kind of building one-off sites for clients, and then we have the benefit of being able to kind of walk away and not have to deal with the impact once it's done. But recently, and I guess not super recently because it was late 2016, I joined the Huntington user experience team as a creative technologist. If you're not familiar with what a creative technologist is, the term that's also been thrown around and gaining a lot of traction is UX engineer. It really just means that I'm a specialized front-end developer that works alongside our visual designers and our user research team to write front-end code, mostly for prototypes and developer specifications. So, that's me. What I know about you. You're at a tech conference, and you're probably a little interested in CSS. This is a big conference. There's over 2,000 people here. I don't know all 2,000 people's background. I'm assuming that they're not all here, but there are only so many theaters. But I can kind of understand and expect that everyone in this theater and the other two theaters come in with varying backgrounds. Some may be more junior, some may be more senior. Some may have come here because CSS is the thing that they really, really like. Others may have used this as an opportunity to say, hey, I specialize in this skill set, but I want to gain more knowledge about this one. Because of that, if you feel like I gloss over anything or don't go into enough detail, feel free to hit me up after this talk. I'm more than happy to go into more details and talk shop about CSS all day. So this talk was originally made for an audience of back-end full stack developers that were having issues with dealing with the ramifications of bad CSS. It was made to help introduce them to and explain a new CSS architectural approach to help fight bugs and defects that our full stack developers were spending far too much of their time dealing with. They get paid pretty well. We work at a bank. And honestly, they've got better things to do with their time than constantly toy with pixel positioning. So let's start off by talking a bit about bad CSS. So for us, when we were talking about bad CSS, we were talking about CSS that was kind of hard to track down where styles were getting applied. We had lots of issues with IDs and importance being patched in and marked as kind of a fix-it-later. Inline styles had kind of become the norm. This was a growing style sheet that had honestly existed since probably almost a decade. And unfortunately, some of the developers were nervous about making changes to the style sheet because they were worried about what the implications of that change might bring. So we kind of understand like what bad CSS is, but bad CSS will, it's going to increase your technical debt. As much as some people may have not liked it back when the style sheet was originally being written, people have got to realize that CSS is real code. It's code that has to be maintained. It has to be updated. And if you just keep patching it, you're going to have to deal with that later. Bad CSS is going to be more prone to visual defects. If it's harder to make updates, if you can't confidently make those updates without knowing what it's going to impact down the line, you're going to break something. And probably the worst part of bad CSS is it's going to cascade into more bad CSS. So what causes bad CSS? Let's first take a look at some organizational challenges. Rushing to meet tight deadlines and unexpected changes. This isn't a CSS problem, it's not a front-end problem, it's honestly just a developer problem. Agile, waterfall, there are always going to be last-minute changes, last-minute or very tight deadlines. In our case, we had several simultaneous projects going on that were modifying the same CSS style sheet. The different developers that were modifying the style sheets all had their own personal coding preferences, and the ones that didn't align to mine were unfortunately wrong. And then kind of getting back to the root issue, and something that I know a lot of front-end developers have struggled with for a long time, is that front-end wasn't necessarily seen as its own discipline. It's not something that people put the same sort of rigor around that they did with their back-end code. Front-end was either something that the designer wrote, or it's something that's just expected that all developers kind of know because it's easy. But with as easy as front-end is, it's important to ask yourself, how well do you know CSS? After I gave this presentation to my developer counterparts at Huntington, this question was asked by Max Stoiber on Twitter. Given these classes, what color would these divs be? I'm gonna sit for a few seconds. I don't expect anyone in this room to answer me. I don't expect anyone to throw up their answers in the Slack channel. You know, it could be embarrassing if you're wrong. So as we get the respondents, we see that 44% of people identified the first one being blue and the second one being red. And then 43% of people said both blue. And that's very unfortunate that we have that sort of misunderstanding. But what's more unfortunate is that the plurality of people were wrong. Now, obviously, this is a Twitter poll. It's not scientific. It's not targeted specifically to front-end developers. But Max Stoiber is a front-end guy. He does a lot of work. He created stylized components, I believe, or one of the CSS in JS frameworks. And I don't show this to like embarrass anyone that got it wrong, including the 44% of Twitter respondents. But it's important to understand that everyone has gaps. If you're working on a team, you're going to have things that you do that seem easy, but other people struggle with. For instance, like I almost exclusively use visual editors for Git. I know a few commands. Most of the time I Google search it when I have to do something command line, when I break the branch somehow. The developers that I work with, much smarter than me in Git. I accept that. So what causes CSS, or what causes bad CSS? A lot of it is due to a lack of knowledge. Specifically, a lack of knowledge on how CSS applies its styles. Given that the plurality of respondents answered this wrong, we're going to do a quick crash course on how this works. So first, when applying styles, CSS will prioritize any property that has important marked. Next, it's going to look at selector specificity. People have described this in a lot of different ways. I've heard the Sith Lord analogy with like Vaders and stormtroopers. I guess if I were being on brand, I'd have done something creative with like Thanos and Avengers and all that. But realistically, like that doesn't resonate with my brain very well. What does resonate very well is kind of version numbering. And even though this isn't a version, the prioritization on how that works kind of makes sense to me. So kind of at the furthest left, if there are any inline styles, that's a 1. You can't get higher than that. At that B range, you count the number of IDs in a selector. At that C range, you count the number of classes, pseudo-classes, and attributes in the selector. And then at that D level, you count the number of elements and pseudo-elements in the selector. And just like versioning, 0.0.1.0 is always greater than 0.0.0.9999. So let's take, let's look at a few examples. So this Captain Marvel div, most powerful Avenger, so put her in the inline style. 1. There's no way to increase it beyond that. You can't really do IDs in an inline style, so 1 is kind of the top. You can't put multiple inline styles. That would just be confusing. Next, this Agent of S.H.I.E.L.D. It has a specificity of 0.0.2.0. The Strong Avenger. It has a specificity of 0.0.1.1. Ant-Man. That ID gives it a specificity of 0.1.0.0. And then Ant-Man in his giant variant has a specificity of 0.1.1.0. And then we have this. The before pseudo element inside of a hovered footer inside of the Mark L suit of Iron Man's has a specificity of 0.2.2.2. Now, obviously this is a very ugly and stupid selector. I'm not gonna say that I haven't written worse. I know I've written things with higher or at least as high specificity. In fact, when I was kind of doing this deck, I went through some of the projects that I had worked on previous to kind of adopting these methodologies and started looking at some of the selector statements that were out in the wild that I had worked on. I'm not sharing them here, a little bit because of my own vanity, but also because it probably isn't the best idea for me to start like pulling in clients that I've worked on and showcase how their CSS is bad. This is being recorded and on YouTube. All right, so next, it'll apply based on sort order. So everything being the same, if the specificities are equal, the thing that's defined lower will override the thing that's defined higher. And then finally, we have to account for inheritance. Inherit tells the browser to apply the computed style of its parent element. In this example, I explicitly set the paragraph's color to inherit, but there are many attributes that default to inherit, and color is one of them. So let's pull this all together. So let's say I'm working on this, this heading 1 tag. I'm looking at it, and right away, based on the CSS for Ant-Man and the no border class and the text align right, I'm expecting it to be a red right-aligned heading with no border, which is not the case. So when I look at some of the other code in the CSS file, start examining what else might be impacting it. Well, as I dissect this, someone marked the heading 1 as text-align center important. That's an example that I use all the time because that's an example that I ran into when I first came to Huntington that just kind of stuck out to me. Next, we have the Avengers H1 that's setting that border bottom to 1 pixel solid red, which, okay, now that we look at it, because that selector specificity is 0.0.1.1, it overrides the later defined no border, which is just 0.0.1.0. And then Ant-Man's color is set to red. Oh, but we've also decided that any H1s inside of the hero ID were going to be green. So those are the sorts of things that can be tricky and non-obvious because you don't always look for those IDs that are kind of nested up, those classes that are nested up on the page. You look at kind of what's actually on the element. This is very much a micro example. I doubt off the top of your head you can think how deep your DOM structure is for any code that you work on, but it's pretty deep. All right, so how do we write better CSS? Well, first, you need to define and agree upon a CSS architecture that makes code easier to read, easier to scale, easier to maintain, and provides predictable application of styles. So that's a good statement, but what does that mean? First of all, write to whatever architecture is chosen, even if you don't like it. This is a team sport. There are going to be times where you have to write code in a way that you don't like, but for the sake of consistency, for the sake of being able to edit it later, for the sake of you 6 months in the future, for the sake of the developer working on it 2 years in the future, try to keep the code consistent. Next, we decided that we wanted to write CSS for systems, not pages. Pages are a really antiquated metaphor for the web. We do more things digital than print nowadays, so it's kind of one of those relics of skeuomorphism. Pages are honestly just the new save icon. And then we want to write the CSS in a way that mitigates the specificity wars. So let's go back to this example and graph the specificity. This was something that Harry Roberts did when he started talking about ITCSS, and I think it really does a great job of illustrating some of the problems with style sheets. So as we go further down the file, we can see these peaks and valleys of selector specificity. So anything that would contradict with that top point later on in the file wouldn't get applied. And this is just kind of using that micro example that we had shown earlier. It can get even more erratic. Basically, as Harry Roberts said, it doesn't matter how well considered your source order is, how well you're utilizing the cascade, what naming conventions you used, specificity can undo everything. So, how do we deal with specificity challenges? Of course, we need to adopt CSS and JS. This is the approach that a lot of the front-end community has started to gravitate towards, including Max Stoiber, the person who put up the original tweet. And a lot of it is because CSS is confusing and doesn't work the way most other languages work. He created stylized components, and it has its place. Unfortunately, the place isn't in our architecture because it can't adhere to the constraints that we had. So when you're defining an architecture for your team to follow, you really have to know what your constraints are. CSS and JS is a tool to solve a problem, is an effective tool, but it doesn't align to our needs. And the reason for that is that some of our applications are using radically different JavaScript approaches. Some are built in web forms. Some are compiled using CMS templates. And some reside in third-party black boxes. And as it turns out, companies aren't necessarily all that willing to rewrite their current tech stack or renegotiate contracts with vendors just to implement your preferred approach of CSS. So, what we could control. Well, we could control the final markup most of the time. We could control the style sheets. What we could not control, we couldn't force the entire tech stack to become some service-driven architecture. And we couldn't control how the backend systems chose to compile the given markup. So understanding our constraints, we chose to implement an architecture based around Sass, specifically SCSS for preprocessing, though you won't really need to understand Sass to follow the rest of this talk. The ITCSS ordering methodology, BEM naming conventions, and BEMIT prefixes and suffixes. So let's talk about inverted triangle CSS a minute. This was created by Harry Roberts, very smart guy, probably my favorite front-end architect to follow. He recognized that the best way to build a maintainable CSS system is making sure that the application of styles flows consistently. So he created these three metrics: reach, specificity, and explicitness. So he wanted to, he defined that you should order your CSS so that the statements that impact the most HTML elements would go on the top. The fewest HTML elements would go at the bottom. The selectors that assign the most styles would go at the top. The fewest styles would go at the bottom. And the lowest specificity at the top and the highest specificity at the bottom. So to follow these metrics, you begin to compartmentalize your CSS into layers. The layers that you're going to need are really dependent upon your organization, and it's more about just making sure that those layers continue to follow the methodology set forth by ITCSS. So first, because we're using a preprocessor, we do have a settings layer. This mostly holds our variables and maps. So if you're familiar with the term design tokens, that's kind of where this would come into play. Next, we utilize a tools layer. This is useful for building functions and mixins. For example, one of the things we were dealing with when implementing this was the mockups were being done in Photoshop at the time, so we had this tracking number, and I got tired of having to manually calculate how I needed to convert tracking to like letter spacing because it's not the same thing. So after the tools, we have the generic layer. This is where we begin to actually see CSS being applied onto the screen. High-level resets, font face declarations, those sorts of things. Next, we have our HTML elements. This layer is using the element specificity space mostly, but I did want to put a special note because of some problems that we ran into around inputs. One common pattern when sort of defining your default input styles is to use like input type equals blah. I'd recommend not doing that in this layer. You can use one or the other, but not both, and that's because if you use the type equals text, that's a class selector. Everything below this level is using classes, it'll override. But if you use the element with the type equals text, it will have that just that extra little bit of specificity that might override a class and cause you problems later. Next, we introduced this bits layer. This layer is one that's more new in the way I've been writing, and it's there to mostly solve those discrepancies between what kind of feels like it should be an element but needs to be a class for various reasons. The example that I use a lot is like a heading for semantic accessibility reasons. We can't just use H1 where the designer tells us to use the H1 styles, or at least that requires a bigger conversation with the design team. So we kind of create this false heading that can be applied to any element and give the styles there. And then I also included this bear class, and that allows me to visually nullify anything that I might have given default values in the elements layer. And you might ask why I would need to override anything, and the answer is because I don't want to have to put a class for lists and links when most of the time those lists and links are going to act a very specific way, and we have content authors managing some of our stuff, so this was kind of a compromise. If I semantically wanted a list but visually didn't, I could just throw the bear class onto the UL and the list items and be fine. Then we have the objects layer, mostly dealing with kind of structural stuff, non-branded design aspects. Grid is a good example of that. Media object if you use it. And then finally we get to like the layer that actually houses most of our Sass partials, and that's components. So that would be the things that you think about like named, a nav bar, a button, the header, the account list. Those things are, would fall in the component layer. Then finally at the very end, we have utilities. The utilities are there for surgical updates. They're the only layer that this approach recommends and encourages the use of important. And that's because if I put a utility class on something, I very much expect that style is going to get applied. And ideally, we stick to only applying one style per utility. So if you see, this helps make sure that when you see text center on something, you know that it's going to be centered. So now we've got all these layers, and then we just have to assemble our style sheet. So the best way to do this is to keep your code into partials if you're using a preprocessor. If not, you're going to have to manually just kind of put the CSS in the right order. In between the layers, it should not matter what order the code comes into. You shouldn't have components that are overriding other components. You shouldn't have objects that are overriding other objects, etc. So this helps us deal with the issue of specificity. But we also wanted to apply a naming convention, and we chose Bem. Naming conventions are important so that when you look at the HTML, you can kind of have an understanding of what is going on even without looking at the CSS. So Bem stands for Block Element Modifier. So first we have the blocks. So these are your high-level classes. This is the thing. When you think about a group of components and you're dissecting them, like this is what you would call the grouping of them. Some of the rules of blocks, you would never have a block being dependent upon another block for styles. Blocks are standalone in their application of styles. Blocks can have elements, and elements cannot have nested elements. So next we'll look at the element. So an element would be a descendant of that block. So if you have a, for example, if you have like a credit card component that you're visualizing on the screen, the card number would be an element of the credit card. As I stated before, elements should be based only on the block. You should not be defining elements off of elements. If you find you get to that place where you have to be, where it makes sense to do that, it may be time to break your blocks into smaller blocks, because a block can always contain another block, it just doesn't affect its styling. And much like blocks, an element should never result in the styling of another element in that block. So next we have modifiers. Modifiers can be applied to blocks or elements. The rules that I follow for modifier, this is kind of a bit, this is where we get a little bit, not everyone's on the same page, but the rules that we've chosen to implement are that a blocks modifier can override its elements. So this does increase the specificity a little bit by having 2 classes instead of 1. But at the end of the day, this made me not have to rewrite that block modifier for every element that I was going to change all the time. So it felt like a better win. And then, much like the rule with elements, an elements modifier should never overwrite another element. So another thing about modifiers. On the HTML, you shouldn't have modifiers without the block also being present. That rule also goes for elements. You should never have an element that exists without its block somewhere up the DOM chain. If I see this, I'm going to get very confused looking for that block. And then informally, this is kind of how we've started ordering our CSS for that application of styles within the Bem class itself. We start off with our high-level block definition. Then we would add the elements inside of the elements, or right after each element, we would have any of the elements' specific modifiers. Then after we're done with all the elements, we would add in the blocks modifier, and then after, then we would apply any changes to the block element based on that block modifier. Didn't always do this. I used to group the blocks, the block modifier up there with the block, but when we started making changes to the elements based on the block modifier, it became really clunky to have my element modifier class defined before my element. So if you're using SCSS, you can kind of scope it and nest it in a way that, that makes it a little easier to visualize. Yeah. All right. So let's see if this works. So over here, I built an example. As I told you at the beginning of the presentation, I went to design school, so I thought I would showcase my design sensibilities. So as we go through the quote and the classes there, first off, I'm ashamed because my spacing is atrocious in here. But we can see that we've got the block class up here, applying the background styles. Next, adding the text, giving it a large variant. So if I go over here and add this large, it'll overwrite, make the text larger. Underneath we have source. Don't really have any modifiers for source. We do have a global block level modifier of fancy, so let's go ahead and apply that. Oh, and I did the thing I told you not to do earlier because I'm live coding and it's a bad idea. So we can apply this fancy modifier, and then we can see how the styles propagate both to the quote and to the quote text and to the source. All right. So thankfully, BEM and ITCSS can play really nicely together. And Harry Roberts realized this and wrote an article describing the approach he was taking and coined it BEMIT, which, as I mentioned earlier, kind of takes the naming conventions of BEM and applies layer prefixes and media query suffixes. So first, let's look at the layer prefixes. So you just prefix the class with whatever layer it would reside in the style sheet. So for B, that would for bit that would be B, object O, component C, utility U. And then for the suffixes, you would use the @ symbol to apply when it breaks. And I use medium, large, and max because those are the breakpoint names that we've defined. Whatever you use internally to talk about those breakpoints is what you should probably use. In this instance, I chose specifically to showcase the compiled CSS version because it's important to know that you've got to escape that @ symbol if you're going to use it in a class name. Because we used a mobile-first approach, we didn't need to worry about defining a small suffix. So now let's take a look at this Bem code. So we have our rows. We have this weird modifier reverse large, color red. We're defining the elements of call, giving its modifier. I'm guessing the dash large means that maybe that's where it's breaking at. But now when I start to implement these prefixes and suffixes, the code becomes a lot more clear. I know where to find that row code. I know that that color red is going to apply after anything that gets applied in that row. One thing that I've also started doing since implementing this approach is trying to be very specific about how I put my classes into the class attribute. Even though the browser doesn't care, it's kind of a nice thing to do if you order it the same way you do in your style sheet. It just makes it a little bit easier for the team to read, and also accounts for the 44% of people that think it works that way anyway. And this is all you really need for most things. For us, we took it just one step further. We're a big organization. When I started, we supported about 4 different kind of sub-applications brands that were all writing things a little bit differently, that all had slightly different looks and feels. So because of that, there were some things that I knew I probably wanted to use across all of them and things that would probably be more specific. So we added in some application namespacing. This isn't innovative, it's not new, it's obviously like it's just a logical next step for our needs based on what's already out there. And we chose to put it between the ITCSS layer and the block. And the reason for this is even if you're dealing with separate applications, the most general utility is going to be more specific than the most specific component. So in this example, we might write C-MV if we wanted a Marvel brand component. We might use AV for the code for an Avengers brand component, and maybe IM for an Iron Man brand component. So now we might have this Marvel page, or more specifically, an Avengers page, but we're resetting it using a global Bear class that is based on the Marvel global standards. Under here, we also have the Avengers roster component, the member div within that roster component, and then we're also pulling in some bits from the Iron Man layer. So what's great to me about this sort of approach, if you're dealing with multiple brands or multiple CSS code bases that might interact with one another, is I can look at any one of these classes and know exactly where I need to go. So we have that, but honestly, we're never done. Once you implement an architecture, your CSS must continuously be groomed and modified. So here are some tips that I have for maintaining your style sheets. Try to implement a versioning and deprecation strategy. Not all your components are going to live forever. So don't let unused code remain indefinitely. You know, unused code really just needs the Thanos treatment. Do propose modifications to the architecture as needed. And I said propose, because don't surprise your team. And I'm saying this, and I know there's at least one person in here that I'm looking at that's probably seen me pull some of those surprise your team shenanigans, like, I'm just going to add something new into the architecture. But it's a bad idea. It's not, this development's a team sport. So in conclusion, now by only looking at the markup, a developer knows the following. It knows the ITCSS layer it belongs to. It knows the application scope. It knows that relationship between the elements in the code. It knows at what breakpoint classes are actually being applied. And with this knowledge, a developer should be able to make changes with confidence. Caution. The flexibility of CSS does mean that any defined architecture is only as stable as the team's willingness and ability to follow it. We can put the best practices in there all day, but if you don't have someone enforcing it, if you don't have someone kind of acting as that, that gatekeeper, when it's coming time to push out code, you know, it's Friday at 5, you know, it's going to be very tempting to start just adding things to the end of the style sheet, adding IDs because you know it'll work. But that's how you get those specificity wars started back up. Another thing I meant to mention but didn't. So another best practice that I tend to follow is when I'm applying styles, or when I'm applying classes to an element, I make sure that I only apply one class per layer, with the exception of the modifiers. So I should never have to worry about whether two objects are interfering with one another, because I shouldn't have two objects on the same tag. And if I do, the solution is probably to just make another div. Yeah. So I do have time for questions, I think.